Tonight, you're taking a one-way trip. You are going to fall into a black hole. And what happens next is so strange, Einstein himself refused to believe it. Outside, your best friend will watch you fall forever. Frozen at the edge, fading, never quite gone. From your seat, you'll be through in seconds. Both stories are true at the same time. And if you park your ship just above the edge and hold on, you could watch centuries of the universe's future play out. In Fast Forward. This is a first-person journey to the strangest place in existence. Buckle up! But before you jump, you should probably meet the thing you're jumping into. When a giant star runs out of fuel, its core collapses. If enough mass crushes together, gravity wins against everything, every force in physics, and the collapse simply never stops. The result is a region where escape would require moving faster than light. And since nothing can, nothing leaves. Not rockets, not signals, not light itself. That's why it's black. And this is not theory. In 2019, humanity photographed one. This glowing ring, 55 million light-years away, is real light, bent around a real black hole heavier than 6 billion suns. Not an illustration, a photograph. They come in a whole range of sizes, from burned-out star corpses that would fit inside a city to the supermassive giants lurking in the hearts of galaxies, billions of times heavier than the sun. So you point your ship at one of these monsters and you begin the approach. The first thing you notice is that the picture is wrong. You can see the top of the disk and the bottom at the same time. The black hole's gravity bends light so hard that the far side is visible over the top, like a funhouse mirror the size of a solar system. As you close in, the stars behind it smear into streaks and rings. The whole sky is being stretched around the darkness like the universe itself is circling a drain. And that glowing disk around it? It's matter screaming as it falls, friction heating it to millions of degrees, feeding black holes power quasars, the brightest objects in the entire universe. Darkness wearing a crown of fire. Then you cross a line called the photon sphere, where light itself moves in circles. Glance sideways here, and in principle, you could see the back of your own head. Think about that, a place where light itself runs in circles forever. And remember, Brythe, you are still on the outside. Now comes the part that breaks people's brains. Because what happens next depends entirely on who is watching. Your friend, watching from a safe distance, sees your ship slow down as it nears the edge. Your clock ticks slower and slower. Your light stretches redder and dimmer, like a scream turning into a whisper. From the outside, you never cross. You just hang there, frozen at the horizon, fading toward invisibility for the rest of time. Your friend could watch for 1 billion years and never see the end of you. To the universe, you fall forever. But in your seat, nothing special happens. No flash, no alarm, no slowing. Your clock ticks normally, your heart beats normally, and you cross the horizon in seconds. You might not even notice the exact moment. And here's the trick you could pull before jumping. Hover just above the edge, engines screaming, and look up. The universe above you runs in fast forward. Stars race. Centuries of cosmic history play out while you burn a tank of fuel. Time is local. The universe never promised it was fair. So you stop hovering, you cut the engines, and you let yourself fall. The event horizon is not a wall. There's no surface, no barrier, no sign that says you've crossed. For a giant black hole, gravity at the edge is so gentle you feel nothing at all. But the moment you cross, the universe quietly locks the door behind you. Every possible path, every direction you could burn your engines now leads inward. Turning around isn't hard, it's meaningless. You didn't hit anything, you just left the universe. Now, about your body, I have good news and I have very bad news. We have actually watched black holes eat. When a star wanders too close, it gets stretched into a glowing river of gas and swallowed. Astronomers have recorded dozens of these events. They light up entire galaxies. Astronomers call it spaghettification. They are not joking. Here's why. Near a small black hole, gravity at your feet is savagely stronger than at your head. Your body gets pulled into a noodle before you even reach the horizon. The good news? Around a supermassive one, the stretch at the edge is gentle. You'd cross intact. Intact. For a while. Because the deeper you fall, the fiercer the stretching grows. Eventually it wins. First your body, then your atoms, then the very molecules they're made of. And inside the horizon, the rules of reality don't just bend, they trade places. Inside a black hole, space and time swap roles. The center is no longer a place in front of you. It's a moment in your future. Avoiding it makes exactly as much sense as avoiding next Tuesday. And here's the darkest joke in all of physics. Firing your engines to fight the fall doesn't buy you time. It costs you time. Struggling makes the end come sooner. The longest life belongs to the one who simply lets go. The only winning move is to fall. And then, the bottom. Except nobody actually knows what that word means in here. Einstein's equations say the center is a singularity, infinite density, infinite curvature. But in physics, when your math starts spitting out infinities, it doesn't mean reality is infinite. It means your theory just ran out of road. To know what's really at the center, we'd need a theory that unites gravity with quantum mechanics. And we don't have one yet. Maybe there's a core of exotic matter. Maybe a knot of pure space-time. Maybe something no human has imagined. The map of physics simply ends right here, mid-sentence, without so much as an explanation. Unless, of course, the bottom isn't an ending at all. Einstein's math contains a strange mirror object, the white hole, a region nothing can enter and everything must leave. A black hole's exit door, running in reverse. The equations allow it. Nature has never shown us one. Spinning black holes are stranger still. Their center isn't a point, but a ring. And on paper, a path through that ring leads somewhere else. Another region of space-time. Maybe another universe. On paper. One more twist. Black holes aren't even forever. Quantum effects make them leak. A whisper called Hawking radiation. Give it enough time, and every black hole evaporates. For the giants, that's a 1 followed by 100 zeros. In years. Some physicists go further. Maybe the collapse inside a black hole bounces and blossoms into a brand new universe with its own Big Bang. Maybe our universe was born exactly this way. The math allows a door. Nature hasn't confirmed one yet. And here's the twist that makes all of this personal. You already live with one of these monsters. This is Sagittarius A star, the supermassive black hole at the center of our own galaxy. 4 million suns worth of darkness, photographed, real, and every year of your life, you've been orbiting it. You've been circling a black hole your whole life. And that monster may be part of why you exist. Supermassive black holes shape their galaxies, stirring gas, regulating star birth, sculpting the spiral you call home. The destroyer is also an architect. So no, you wouldn't survive the trip. But the fall itself taught us where our physics ends, where time can point downhill, and how much of reality is still unmapped. Not bad for a place you can't even see. So honestly, if a ship were leaving tomorrow, would you take the one-way trip? Tell me below. And subscribe, because the universe has plenty of one-way doors left to explore.